Okay, so when we started out, we found the derivative of e to the x, and then we generalized that to any base. Then we found natural log of x, but of course, natural log is just log base e of x. And so now what we're going to do is we're going to generalize this to any base of a logarithm function. So let's start by rewriting log base a of x as log base e of x divided by log base e of a. And of course, hopefully you remember that log base e is the same as natural log. And so what we've got here is natural log of x over natural log of a. So we'll rewrite this one more time. I'm going to write it as 1 over natural log of a times natural log of x, which means that the derivative of this function with respect to x is a constant term times the derivative of the function. Wow, that was super easy. The derivative with respect to x of log base a of x is 1 over the natural log of a times 1 over x. All right, let's use this in an example. This will be example 4, and we will start with the function y equals log base a of a to the power of sine of x. Now, fairly complicated looking function, but let's split it down into outer, middle, inner. First of all, my outer function is log base a. My middle function is a to the power of something. And my inner function is sine of x. So let's take the, whoops, still in red, want to be in black. There we go. The derivative of y with respect to x equals, first of all, the outer function. We have log base a of u, log base a of some function. So the derivative of that, of course, is, and I'll switch to green, 1 over natural log of a times 1 over u. Times, all right, off to the middle. The derivative of a to the something is natural log of a times a to the something. All right, so far so good. I just scrunched myself out of room, so I'm going to move that a to the something, a to the u up here. And just very quickly note that that was my outer, this is my middle. And finally, derivative of the inner, the derivative of sine, of course, is just cosine. All right, let's do a little simplification. Well, I've got a natural log of a and a 1 over natural log of a. I've got an a to the sine x and a 1 over a to the sine x. So the derivative of this is just cosine. Well, had I been thinking a little more clearly, that was intentional, I could have just taken the sine out front of this function because I know that that's a log property. And log a, of course, is just 1, which means that this function was really just y equals sine of x, and the derivative is cosine of x. So, but that's why I did it that way, so we would get the opportunity to see all of these piled on and know darn well that we got the right answer. Okay, if you're in one of my classes or following along, why don't you go ahead and do exercise 23. And we will be back with the next video in which we are going to talk about the power rule using real powers. All right, thanks for watching.